Brett and I, we're doing two things at the same time. We got this KitBot frame with some pre-assembled electronics to help us get through the 3 days quicker from Wright, but the frame plus the bumpers are larger than the allowable volume. Guys, read the rules. Rule 2 and Rule 3 include the bumper in your allowable volume. So definitely take a look at that. We noticed that, so we're at the same time trimming down the frame to allow for the bumpers to get on here, and we're building up the mechanism or the bracing that will hold our climber. The key about that is we're making it a modular design, so 4 bolts, pull it off, it goes onto the other frame once it's cut out. So that's what we got going on at this time.
We're currently working on the gearbox to intake the rope into the robot so we can accomplish climbing. This gearbox did have a metal smooth intake right here to turn, but we took that out. And then we're going to use a belt similar to this to be able to turn and intake the rope onto the robot better and be able to lift the robot. And right now I'm just kind of switching out the two systems.
We're actually trying to take apart the afterburner winch assembly that we're going to use as a braking mechanism and primary power source for our winching mechanism. It won't be the exact design that you can get off of Andy and Mark off the shelf, but we're modifying it for using with our pulley system. And once I get it apart, we're actually going to mount this transmission to it and then put it back together and put it on the robot, and hopefully it'll work.
So I am currently building some converter cables for the encoders. So the encoders currently are plugged into the GPIB ports of the RoboRio, and we want them on the Talon SRX ports. So what I've got the Talon SRX breakout, and what I'm doing is I'm going to just create cables that go from the breakout to the pins that normally go into the GPIB on the RoboRio. So that is what I'm working on.
So we're working on the climber right now, and we've got the climber mounted, and we need to mount the transmission that just got completed. And to do this quickly, what we decided to do, REV Robotics generously donated us their extrusion. This extrusion is good for a couple different reasons. The first one is that you can use the pattern inside the extrusion is such that you can use bolt heads and specifically number 10 nuts into the extrusion and then just connect directly to it, which makes it nice that the hardware that you already have or that you can buy locally can be used with the extrusion. The second thing is it's super easy to cut. So right now we actually don't have any number 10 nuts. We've run out to go get them, but just as a size fit and to show how it all can come together, we're using the top of the bolt. And what I'm going to do is I'm just going to easily slide the extrusion through. I cut it on the chop saw, And there you go, now it's in the proper place. And then we can do the exact same thing over here. I'll lift that up for a size fit, put it in, and then do the same on this side. And as you can see, I've now got my bracket. Although it's not tightened down, what I can do now is do my fit for the transmission. We're gonna mount the transmission on top of this rail, like this, which then allows us to move the transmission back and forth once the mount is complete to actually tension the belt, which is the actual goal of why we're doing all this. So the extrusion was A, easy to cut, B, easy to mount, and C, easy to align and tighten our component, which saves us a lot of time in the robot in 3-day build. Thank you, REV Robotics.
Almost there, but not quite all the way there. Really? That chain is our clutch. Yeah, that's it. We designed it that way.